In this video, we're going to talk about disjoint and independent events and how they're different from one another so we can stop being confused by them. So let's say in this scenario, of adults who are online, 71% of them use Facebook, 26% use Instagram, and 24% use both of those social media platforms. So let's first draw a picture of what this is going to look like. And we're going to use a Venn diagram to visualize our probabilities, or these percentages. So first, our Venn diagram starts off with roughly a rectangle, something like that. And then it has circles, which represent the different events. So I'm going to let Facebook stand, FB, stand for Facebook. Instagram is going to be IG, so I don't have to keep writing those words out. So we're going to have two circles here. This is the first one. It will be Facebook. It can be a circle, it can be a blob. The idea is that it just represents a section of space. If this Venn diagram represents 100% of people, then these sections here represent another percentage that are occurring for each event. I'm not drawing them to scale. I could, but I'm not going to. All right, here's our second event. So the second event there is Instagram, and then that first event was Facebook. Typically, Venn diagrams aren't drawn to scale. Then there's this overlap right here. So everyone who's in that blue circle are people who are adults who use Facebook, are adults online who use Facebook, and then everyone who belongs in that green circle represent adults online who use Instagram. And then there's this overlap section in the middle because there are 24% of people who use both. So I'm going to fill in some of these numbers right here. So we had 24% of people who use both. And I'm going to start with the middle section because that is the most specific out of all these probabilities. The 71% of adults that are using Facebook, it is just, if you had people in a room and you said, do you use Facebook? They'd raise their hand. 71% of them are raising their hand. You ask the same group of people, how many of you use Instagram? 26% of them raise their hand. But then there's the people who use both of them, and they were double counted. Some people use Facebook, some people also use Instagram, and there's our overlap. So this other section that in the middle, those are the people that raise their hand twice, but then there's people on the outside right here. Those are the people that only would use one of those social media platforms. So I'm going to do a little subtraction. So Facebook users, 71% minus the 24% that also use Instagram. Do some subtraction. We have 71 minus 24. We get 47%. 47%. So here's, let's use the right color. So the blue, here is that 47%. All right, so over to Instagram. There are 26% who use Instagram, but there's that 24%, which is an overlap. So that leaves 2%. So here's 2% over here. Those are the people that are only using Instagram because we've removed the overlap of those people that also used Facebook. Notice how this is not to scale. 47% takes up about the same area as 2%, so don't let that confuse you. But then we have this outside area. What about out here? This box represents everyone. It's 100%. So I've used 47%, I've used 24%, and 2%. I've accounted for that much percent in the people, so I need to find the outside area. Maybe I'm asked a question about it in a later problem. I'll take 100% minus the 47% minus the 24%. and then minus the 2%. So 100 minus 47 minus 24 minus 2 leaves us with 27%. This here in the outside area, and that's strictly outside area, that is 27% of people. Oops. You could say that 27% of people use neither of those social media platforms. All right, so I just made that diagram to get a picture and play with these numbers a little bit, make sure we know how to read the Venn diagram. So let's ask a question. Are the events using Facebook and Instagram disjoint? So that's our keyword here, disjoint. Well, we have to figure out what it means. If the events, Facebook and Instagram, are disjoint, it means that it's impossible to have both events happen at the same time. So there's the keyword, same time. And in this case, since we are having people raise their hand, it's like we are looking at the same person and their hand that went up because they said, do you use Facebook or Instagram? So is it possible to have a person that raised their hand for Facebook and raised their hand for using Instagram? Yeah. So the probability of using Facebook and Instagram, we ask, was it equal to 0? No, we did find people who used both. The probability that someone used Facebook and used Instagram for their social media, it was given to us in the upper part of the problem. It said that 24% used both. So the probability is not 0. If 0, then we would have disjoint events. So we actually got a number here. We got 24%. So in the end, we're going to say not disjoint. So that's all we have to do. We have to look for an overlap. Can some person have both of these qualities in them? Yes. So we have not disjoint events. All right, let's take a look at independent events. So this is a totally different question. We're not asking a question about the two qualities being in the same person. We want to know if one event will change the probability of the other event happening. So if events are independent, they have no effect on each other. Being on Facebook won't change your chances of being on Instagram. Being on Instagram will not change the chances that you're on Facebook. So what does it mean for these events to be independent? If an adult is on Instagram, it would not increase or decrease the chances of them being on Facebook, or vice versa. You can just exchange the words Instagram and Facebook, and you still are giving a sentence that talks about independence. So the way we have to check that is very specifically. We need to check this rule. Does the probability of being on Facebook equal the probability of being on Facebook given, remember that little vertical bar means given that someone's already on Instagram? So if your friend is already on Instagram, does that increase the chances that they're also on Facebook? Or is it pretty much straight across the board, doesn't change a thing? So we pose this question, and now we find the two probabilities on either side and check if they're equal. So I'm going to leave this question mark right here. What's the probability that someone's on Facebook? We go back up to the top, 71%. So we're saying 0.71. Is that equal to this conditional probability? So I need to write out this conditional probability a little bit more. This conditional probability is equal to a formula. The probability of Facebook and Instagram, so the chances of someone being in both, divided by the probability that someone is on Instagram. And that's just the definition of conditional probability right here. Definition, conditional probability. So go to your book, look up that definition, we rewrite it, because now these two pieces, the numerator and the denominator, I know those numbers. 0.71 equals, all right, let's start plugging in numbers. What's the probability that someone is on Facebook and Instagram? If I go back up to my Venn diagram, the probability of being in both is 24%. So 0.24 becomes my numerator, divided by the chances that someone is on Instagram. So go back up to the top. This whole entire green circle is 26%, just like it told us there in the problem. 26% of people are on Instagram. All right, so let's look at this fraction right here. The conditional probability is saying out of the 26% of people just on Instagram, this numerator, 24%, is also the people on Instagram as well as Facebook. So it's the proportion that are on Facebook out of the Instagram crowd. Do some math. We want to see if these guys are equal. So actually, let's throw back in my equal sign. Are these equal? Are these equal? Now go to the calculator. 0.24 divided by 0.26, and we get 0.92 about. So are those two numbers equal? No. I'm going to put a slash through this. These numbers are not equal. So what this is saying, 71%. That is the plain old chance of someone being on Facebook. Okay, if you looked at the crowd, 71% of them are on Facebook. What does 92% mean? 92%, that is the chance of someone being on Facebook knowing, that's another way to say given, knowing they are on Instagram. So if someone's on Instagram, there's a 92% chance that they are also on Facebook. That's much higher than just picking a random person, not knowing anything about if they're on Instagram or not. So the probability has increased. Knowing that information, knowing that someone's on Instagram, it changes the probability that they belong on Facebook. So because these numbers are not equal, these events are not independent. Being on Facebook and being on Instagram are not independent. So the whole idea is that knowing someone was on Instagram changed or increased the chances that they are on Facebook. So we have not independent events. Some textbooks might say that it's dependent events. Knowing that you're on Instagram changes the chances that you will be on Facebook. So let's recap here. Independent events are all about changing probabilities. Let's go back. If we know a little bit of extra information about someone, does it change the probability of some other event happening? Yes, in this case it did. Disjoint events are all about events happening at the same time. Can you have two different qualities in the same person at the same time? Yes, you want to look for the and probability and see if it equals 0.